This code is designed to control a robot with two large motors connected to its wheels, allowing for it to perform right and left turns in a controlled way. The program defines functions to make the robot turn 90 degrees left or right. The code imports the necessary libraries. The time module is used to add delays between actions, allowing for precise and accurate turns. The EV3 Dev2.motor module provides access to monitor control functions for EV3 motors. The motors are initialized as large motor class is used to create motor objects for motors connected to the output ports A and B. Motor A is assigned to the left motor and motor B is assigned to the right motor. These assignments will help allow the robot to move by controlling each wheel independently. The constants motor speed and turn time set the motor speed for turning with a value of 200. This can be adjusted for smoother or faster turns. The turn time sets the duration 1.2 seconds. The motors will run during the turn. The timing is calibrated for a 90-degree turn and can be modified for more precise angles. The turn left function is set to move backwards at the motor speed, and the right motor is set to move forward at the same speed. The combination of opposite directions causes the robot to rotate left. Time.sleep, turn time pauses the code for turn time seconds, allowing the motors to run long enough to complete the 90-degree turn. After a sleep period, both motors stop with the hold stop action, locking them in place to prevent a drift after the turn. The turn right function operates the same to the turn left but reverses directions of both motors. The main code execution. So the program tests the turning functions by first calling turn left followed by turn right. It prints message to indicate the current action. Time sleep 1 adds a pause between each turn for easy observation. This allows us to observe each turn in isolation and ensure the function works as expected. Turn left and turn right control the direction and speed of each motor to achieve 90 degrees. Motor speed and turn time control the speed duration, which is essential for fine-tuning the angles, the turning angles. The main code execution runs
Okay, so here's my code, my comments, and with the repeat 2 times, it's just going to do it multiple times. And the move tank left, speed, and right, that's going to make the wheels just go forward. And I made it go forward for 3 seconds. And then to get it to go backwards, you do it a negative, and that causes it to go backwards. So yeah. The reason we need our robot to move forward and backward is so we can just get crops back and forth from the healthy and nutritious crops to the dead and just get them back and forth. So we just have to get the basics down and how exactly we're going to get the code, make the code, and then we're going to just keep doing test runs and trial runs. In this project, we really didn't have much difficulties, that's why you didn't see our team. But a difficulty that we had is we lost an astronaut, we lost a member. They went their separate ways. That was a difficulty we had because she was a very big asset to our group. So we had to learn how to manage and take more part. And with this project, there wasn't set people. So that caused all of us to do one big thing and find our parts and communicate with testing and all that. How did we resolve them? We just communicated, talked more. We talked like, okay, this person's going to do this. And in our PowerPoint, like in our document, we put a name of who's going to do this. And what I learned from this project is you really have to be on track or you will not get this project done.